Hello, guys, and welcome to today's meetup of PIEANDAI. Today, I have Ramsri with us, who is an entrepreneur, and um, he'll be teaching us about AI and NLP. NLP using true and false generator. So let me welcome him to the call. Hi.
Thanks, Manpreet.
Yeah.
Are we good to get started?
Yeah, but would you like to introduce yourself in detail to our audience first?
Sure, absolutely. Yeah, thanks a lot, Manpreet, again. And I've been following your work and I've been connected with you for quite some time. Finally, great to be here on a live stream.
Thank you. It means a
Yeah,
lot to me as well.
great. So, I'll introduce a little bit about myself to the audience, and then we can go over the topic of question generation, true or false question generation. Great. So, I'm Ramsri. I've been a lead data scientist with almost 8+ years of work experience across Silicon Valley, Singapore, and India. And most recently, I also had a funded AI startup based out of Singapore. I was co-founder and CTO of it. And coming to the topic of question generation using NLP, I worked on the exact same problem for the last 2 years. And today's topic is a submodule in the question generation, which is to generate true or false questions using NLP. And my website is ramsri.ai. So if you want to get connected on LinkedIn, Twitter, and find all those social links, you can go to ramsri.ai and get connected with me. And if
Thank
you are
you.
good, we can get started. Manpreet,
Yeah,
go ahead.
yeah, we have few users joining us. So,
Okay.
yeah.
Should we wait for a few minutes or how do you suggest?
We have like 10 people. We have on LinkedIn as well as on YouTube people watching, so I guess it's good to go.
Okay, great. Awesome. So I always love to start with a problem. So before even going into coding or natural language processing, any of the AI techniques, the first thing is to understand a problem that exists in the real world. Then we need to come up with potential solutions to solve that problem. And in our previous startup, we worked on this problem, which is to generate questions automatically. So just to give you more context, if you pick up any middle school textbook, maybe like science, social, or English, at the end of every chapter, you would have seen question types like multiple choice questions, true or false questions, fill in the blanks, and other types of questions, right? So uh, in this section, we are going to see how to generate true or false questions. So what's the business use case for building such a system? It's that right now, if you take any textbook publishers, let's say Pearson, Oxford, or McGraw-Hill, these people create questions at scale. So they have content prepared. Now they need to create some assessments or quizzes from that content. And right now it's done manually, where someone will read the content and generate some questions. Those questions could be multiple choice questions, true or false questions, or any of these types. Now, usually, if they don't have an in-house team, they outsource this process. So they outsource this process of question creation, assessment creation, and of course, it involves quite a lot of cost, time, as well as rounds of revisions, because you get back the quiz, then you need to evaluate whether it meets your quality standard, and then again you need to do some rounds of revision to let it come to the quality standard that you have internally. So assume that you are hired as a data scientist within these textbook publishing companies, and now your goal is to develop a tool such that the tool can take in text or some content or chapter and it will automatically generate assessments. And in this section, we are going to see how to generate true or false kind of questions. So if you just look at the content right here, and one question that is generated as true or false is this: the Nile River begins near the equator in Africa and flows north to the Atlantic Ocean. Now, the original sentence has Mediterranean Sea. Now you're replacing Mediterranean Sea with Atlantic Ocean, and you're giving it as a true or false question. Um, the student is supposed to read this sentence and recollect and answer with a true or false. So this is how the flow works. Now, if there's a teacher, they would read this content and automatically they would create some true or false sentences and give true or false options accordingly to whichever is the correct answer. Now we are going to use state-of-the-art NLP techniques and achieve the same thing. Now let's just take a moment, and if you want to use question generation in your workflow of NLP or AI, we have already released an open source library for question generation called Question. You can find it at this link. And also the code that we'll be going to see today, as well as the slides that we are currently seeing, are available at this link, bit.ly/NLP by Ramsri. So if you want to follow along with the code or have this presentation as your reference as well, you can go to this link and download all the necessary things. Great, we can get started. Now we are tasked with this problem of generating true or false sentences. But before jumping into what are the NLP libraries, techniques, etc., let's try to understand this problem in further detail. So how are true sentences generated? So one way is, let's say you have a large block of text, a story or context or some chapter. One way is that we identify the top 5 or 6 sentences from that paragraph or context, and all those sentences are directly taken from the paragraph or chapter. So they could be given as true sentences. So you can give that sentence as it is and ask true or false. And of course, in this context, the answer is true because you are directly picking sentences from the paragraph. And one way to do this is use some kind of summarization techniques. So using NLP, you can take your, let's say, 100 sentences context or chapter and automatically identify the top 5 or 6 sentences. So you can use some summarization, NLP summarization technique to identify the top sentences, and you can give each sentence as a true sentence. But if you go out in the wild and see how things are done actually, usually you don't give the sentence as it is, because sometimes you have a compound or complex sentence and you convert that into a simple sentence. Let's take a small example. Let's say the original sentence in the paragraph is this: because I had to upskill myself in my job, I embarked on a deep learning journey with Andrew Young's courses. Now, somebody, let's say a teacher, could read this and they could just use one sub sentence from it. So this is a complex sentence. From the complex sentence, we are extracting just a part of it, and you can give that as true or false. And in this case, it is true. So you can just take, I embarked on a deep learning journey with Andrew Young's courses. So you have split the complex sentence into a simple sentence and you have given that sub sentence. Now you can give this as true or false. Again, another sentence: PIEANDAI talks are usually scheduled on Saturdays, yet many attend it despite being a weekend. Thanks for all those who are attending it currently. Now, if let's say there's one such sentence, you convert again this compound sentence into a simple sentence and take only the sub part of it. PIEANDAI talks are usually scheduled on Saturdays. Now you can give this as a true sentence. So in short, you can take a compound or complex sentence and take only a part of it that stands by itself, and you can give that as a true sentence. So this is one of the way how teachers intuitively do this. Of course, they don't use all these heuristics. They naturally read the text, naturally summarize the text into top sentences, identify that naturally, and also from that give from compound sentences and complex sentences, find a sentence, simple sentence, and give that as a true sentence. Now we have seen how true sentences are generated. Let's see how false sentences are generated. So false sentences can be generated in several ways. So we will discuss all those ways. So one way is we can add or remove negation to a verb phrase or noun phrase. Verb phrase means a main verb along with supporting words to it. Similarly, noun phrase means there is a main noun and there are supporting words to it. So let's say in this sentence, the amount of change in a chemical reaction doesn't change. If this is the original word, original sentence, then you can falsify this sentence by changing doesn't change to changes. So you are negating the verb phrase and you are giving it as a false sentence. Now another example, grasshoppers can fly. You can just change that to grasshoppers cannot fly. You can negate the verb phrase and you can give it as a false sentence. And another sentence, attendees have found the talk by Ramsri interesting. You can change that into a false sentence by just replacing the noun phrase by no attendees have found the talk by Ramsri interesting. So here we are negating the noun phrase. So we are falsifying the sentence here. But you would know uh, in here we are taking this original sentence and we are falsifying the sentence here by just replacing the noun phrase with a negative phrase. Now going on to another type of how do you falsify a sentence. So one is changing a named entity. Named entity could be like year or company name or person name, any of these named entities. So the Declaration of Independence was signed in 1776. Now to falsify the sentence, you can perhaps change the year to 1812. Another example, Manpreet works as a data engineer at PACT. This is an original sentence. And now you can falsify that sentence by changing, let's say, PACT to O'Reilly. Now you have a false sentence. Manpreet works as a data engineer at O'Reilly. Now in this context, that could be a false sentence, but we never know if Manpreet gets a better offer from O'Reilly tomorrow. This could be a true sentence even.
Competitors.
Yes. Now one more way is changing the adjective. So let's say the scariest villain of all time is Darth Vader. Now you change the adjective scariest to softest. That becomes a false sentence. And Tom was huge and angry. You change that to Tom was tiny and scared. It's a false sentence again. So third way is changing by adjective. Moving on, one more way is to change the main verb. So when electrons are shared between two atoms, a covalent bond is formed. So you can change the main verb that is shared to something else. And now you have a false sentence which reads as when electrons are transferred between two atoms, a covalent bond is formed. Now other way is to actually have an not a negation but an alternate verb phrase or noun phrase. What does that mean? Let's say you have this sentence, Aunt Avanti was sitting in an armchair watching the rain-washed trees and blue sky. Now this whole thing, in an armchair watching the rain-washed trees and blue sky, the whole thing is verb phrase, and now you can change, you can remove that verb phrase and have an alternate verb phrase or noun phrase, and you have a falsified sentence. Aunt Avanti was sitting on the sofa watching television. So this is one way where you're not negating, but you're replacing with an alternate noun phrase or verb phrase. Now, in this section and in this tutorial, what we are going to see is that we are going to see how we can take a sentence and find the verb phrase or noun phrase in it and replace that with an alternate noun phrase or verb phrase. So this is what we are going to do in this, where we'll use state-of-the-art NLP algorithms to convert a sentence into an and replace the verb phrase or noun phrase in it with an alternate verb phrase or noun phrase. So among all the 6 types that we have seen how to generate false sentences, so for few types, like where you are doing negation or replacing the word with an antonym, synonym with an antonym, etc., you can use things like wordnet, etc., or even some thesaurus to find the antonym for that word, the opposite word, and replace that word with an opposite word, and you can get a falsified sentence. But we are going to pick the hardest of all, which is to replace with an alternate verb phrase or noun phrase, and we are going to see how we can do that. So one way is you can take the original sentence, then you can do constituency parsing on it to find the ending noun phrase or verb phrase. Now once you find the ending noun phrase or verb phrase, you can remove that ending noun phrase or verb phrase and have the split sentence. Now with this split sentence, you can very creatively use OpenAI GPT-2 or any other sentence completion algorithm, and you can ask OpenAI GPT-2 to fill this partial sentence, and it can come up with several alternatives. And one alternative could be the old man was sitting under a tree and looking around at the bushes. So now you have a false sentence that is different from the original sentence, sipping coffee. Now we have replaced that with an alternative verb phrase or noun phrase. Now going just a little bit deeper, so you can take any sentence, go to this link right here, Allen NLP constituency parsing, and if you place the sentence in there in the demo, online demo that is available, and hit run, it will split the sentence into its constituents. So you can clearly see the old man is the noun phrase and this whole thing is verb phrase, was sitting under a tree and sipping coffee. And again in this verb phrase, again it is divided into subverb phrases and noun phrases. So if you go through the tree, you can see that there's a noun phrase called sipping coffee. There's a noun phrase called coffee that is combined with sipping coffee and it becomes a verb phrase. And similarly in the tree structure, you can see that it is combined, and now the original sentence is divided into its constituents. And what we are going to do is that we are going to use constituency parsing to break this sentence into its subphrases or constituents. Now among the constituents, we are going to find what is the ending noun phrase or verb phrase. So here in this sentence, sipping coffee is the verb phrase, coffee is the noun phrase. Now we are going to find the ending noun phrase and verb phrase and split the sentence there and give it to GPT-2 to let it fill with alternative verb phrases or noun phrases. Now, as I mentioned, now you have the split sentence. The old man was sitting under a tree, and now if you give this to a GPT-2 transformer model, it can generate and fill this sentence. This is like an input prompt, and it can fill this input prompt with alternating endings, and you can use all these alternating endings as the false sentences. Now we'll use one more interesting trick, because let's say you have this original sentence, the old man was sitting under a tree and sipping coffee, and you ask GPT-2 to come up with alternative sentences. So GPT-2 came up with these alternative sentences: sipping tea, drinking beer, and looking around at the bushes. Now, technically speaking, if you take this sentence, sipping coffee, and old man was sitting on a tree and sipping tea, if you give this to the students, they don't know whether it is actually a false sentence or you just rephrased it. A false sentence should have completely different meaning. So among all the things that are generated by GPT-2, again, you want to find the most dissimilar ending. So sipping coffee and sipping tea are close. Maybe drinking beer is also close. But looking around the bushes is far away from sipping coffee. So if GPT-2, let's say it generates 10 sentences, among those 10 sentences, again you want to find the sentence that is the farthest from the original sentence. So we can use again sentence transformers. So we'll use sentence embeddings and we can compare the embeddings and see which sentence is the farthest. So we'll use sentence bird in our case. From all the 10 generated sentences, we can again sort them by similarity using these sentence transformers or sentence embeddings, and we can find the most dissimilar sentence and give that as the false sentence. Now we are done with the theory session. Some of you might ask, show me the code. So we are going to see in live how we can use the same thing and use Hugging Face Transformers library and Allen NLP and do the same thing in code and achieve what we want. Yeah. Okay. So in code, so as I mentioned previously, if you go to bit.ly / the link that I mentioned, NLP by Ramsri, you can get access to this collab notebook. And right now I'm connected in Google Colab and I'm just running the first cell. So in this cell, I'm going to install Allen NLP that is used for constituency parsing. Then I am also installing Spacey here. It will just take a few seconds and I think we are done. Okay. Now we are just importing Spacey and also loading the small Spacey model that is used for finding verbs and other things. Now in this cell, we are actually going to download the constituency parser that we are going to use. It will just take a few seconds and it should be ready to run. Now we are going to use our test sentence that we have seen previously, which is the old woman was sitting under a tree and sipping coffee. So this is the original sentence that we have been referring to. And all we are doing is run this sentence to the constituency parser that is loaded here in the predictor object. And we are going to print the parse output. Now, if you see, we got the parsed output here. Let's just print it as a tree string. So what's happening here is that a sentence has all its constituents like verb phrases, prepositional phrase, there's a sentence, and then there's determiner, the, etc. So the original sentence, the old man was sitting under a tree and sipping coffee, that is split into its constituents, and each of the constituents are named accordingly, whether they are noun phrase or verb phrase or prepositional phrase, etc. Now, this might not make sense for you. It will make sense for you when you actually print it out as a tree object. That's what we are going to do here. So we are going to use NLTK and print the sentence as a tree object. So this is the original sentence. The old man was sitting under a tree and sipping coffee. Now it is split into this tree object where there is a hierarchical uh, recursive tree object, and you can see that it is divided into its constituents like this. Now at the top level you have this sentence, and immediately there is a noun phrase, the old man, and there is a big verb phrase, was sitting under a tree and sipping coffee. And your goal is to recursively go through the right branch and find the ending verb phrase and ending noun phrase. So if you go through the right branch here, you can see that the ending verb phrase is sipping coffee and ending noun phrase is just coffee. So we are going to see and extract the same thing, which is ending noun phrase and ending verb phrase. Now if you want to know more about what are all these terms, noun phrase, NP, determiner, DT, and all these things, you can go to these links here and you can learn more about what each of these stand for, like S for sentence, noun phrase, prepositional phrase, determiner, etc. So a sentence is divided into all its constituents, and if you want to know all the constituents that we get, you can look into these links as well. Now here, I'm just showing for demonstration purpose that if you take the top level tree and print, it looks like this. But if you just take the 0th index and the first index and print, then you can get the sub noun phrase. So 0th index points to this and the first index is this. So what I'm trying to say is that you can recursively find, and it's like a nested list where at the top you have sentence and you have two elements underneath it, noun phrase and verb phrase. And underneath that, again, if you go into sub nested elements, you have this determiner, verb phrase and noun phrase again. So I'm just printing out the sub trace so that you can see the nested elements here. Now, what I'm going to do in this section is to actually split it at the rightmost noun phrase or verb phrase. So as I mentioned previously, in this sentence, we are going to recursively go through the right branch and capture the ending noun phrase and also the ending verb phrase. Sorry, we are going to capture the ending verb phrase sipping coffee as well as the ending noun phrase. So recursively we will go through this and find the ending noun phrase and verb phrase. So that's what is happening here. So all the recursion is done in this small function where you are passing the parse tree, and if you are at the end of the parse tree where there's only one leaf, that is you are at the very end, then you are returning the last found noun phrase and verb phrase. If not, you are going to recursively get the rightmost parse tree and you will pass it to this recursion function and again capture the last encountered noun phrase and verb phrase. That's what is happening here. Once you run this cell, it will be evident for you. The original sentence is the old woman was sitting under a tree and sipping coffee. Now we extracted our tree object using our Allen NLP constituency parser. Now you passed the tree object to this function, get rightmost verb phrase and noun phrase, and it returned the rightmost noun phrase as coffee and the rightmost verb phrase as sipping coffee. Now you have extracted sipping coffee and coffee as the rightmost noun phrase and verb phrase. And what you are going to do is to find which is the longest in this, because we want to find the longest, which is sipping coffee, and split this sentence at sipping coffee and just give this sentence to our GPT-2 algorithm to let it fill. So here I am just doing some heuristics where once you found the longest noun phrase or verb phrase, among noun phrase and verb phrase, you will find the longest one, which is sipping coffee. Now this is the original sentence. And now you found the ending phrase sipping coffee, and you'll remove the ending phrase from this original sentence. Ideally, you can just do a string comparison and remove this, but there is one catch here, because when you're doing the constituency parsing, uh, actually the spaces are not preserved. So if your ending phrase has, let's say, 5 spaces, you have sipping 5 spaces coffee, and you're just trying to, in the original sentence, if there is sipping and 5 spaces coffee, but in your ending noun phrase from your constituency parser, you'll only get sipping 1 space and coffee. So you cannot do a direct string comparison. So I wrote a small function to get termination portion, because it will combine everything and get the termination portion. It will recursively find the termination portion. Just because the spaces are not preserved in our constituency parser once you get the tree object, I had to do this small hack. But at the end of the day, all you're doing is, from the original sentence, you're going to remove the ending phrase and get the sub split phrase, which is the old man was sitting under a tree. And now I'm going to just show another example, because sometimes you want more variety. And what I mean by that is, you don't want to split at the ending noun phrase or verb phrase. You rather want to split it at the first encountered verb phrase or noun phrase. So let's just see that example as well. Now I have another sentence. They had no ice cream left at home, nor did they have money to go to the store. Now again, remember that the tree is not a binary tree. It's a multi-array tree. So if you see here under sentence, you have 4 branches. So in a binary tree, you have only 2 branches. Here you have 4 branches. And every time we are going to go to the rightmost branch and find the verb phrase or noun phrase. So previously we have split at the ending noun phrase or verb phrase. So in this sentence, ending verb phrase would be go to the store, and ending noun phrase would be the store. We would find the ending noun phrase or verb phrase. But just for a change, because depending on your needs, you might want to split it at the very first encountered verb phrase and noun phrase as well. So here we are going to see how we can find the first verb phrase, have money to go to the store, and also the first encountered noun phrase, money to go to the store. So just for a change, in here I am going to find the first noun phrase. So in the same recursion function, I just modified it a little bit so that I'm only preserving the first encountered noun phrase and verb phrase. I'm just showing this example because depending on your custom logic, you can split the sentence in any way that you want and get the split sentence, and then you can give that to GPT-2. So in this use case, we are actually splitting at the first encountered verb phrase or noun phrase. So this is the original sentence, and you split it at the first encountered noun phrase or verb phrase. So you're going to remove the complete money to the store from this sentence and have only this subsplit sentence, which is they had no ice cream left at the home, nor did they have dash. Now you can use GPT-2 to fill that. All we have seen is that there are all we have seen is 2 ways of splitting the sentence: at the ending noun phrase or verb phrase, or at the first encountered noun phrase or verb phrase. Now, once we have our split sentence, we are going to see how we can use GPT-2 to fill the sentence. So I am installing Hugging Face Transformers library here. That's what is happening, as you see. And I'm going to download the GPT-2 model. So I'm using pre-trained GPT-2 and downloading that here. Now, depending on your use case, you can use distilled GPT-2, which is a smaller version of GPT-2 that is lesser in space constraint as well as it is faster. So depending with slight compromise of quality, you can use a smaller version and also a faster version of GPT-2. Now we are coming to our main crux of the crux of the problem, where you have a partial sentence. The old woman was sitting under a tree, and now you are going to give this to GPT-2. All I'm doing here is to tokenize this partial sentence using the GPT-2 tokenizer. So what does tokenizer mean? So algorithms do not understand sentence as it is. So you need to split the sentence into what algorithms understand. So simple tokenization could be you split on the space. So the, old, woman, all these individual words could be individual tokens. But when you go to complex models like transformers, perhaps you want to split it even at subword level. What I mean by that is sitting could be split into sit and ing again. So subword again. So GPT-2 uses its own internal tokenizer to split it into subwords, and all these are token IDs within the GPT-2's tokenizer. So each of this token ID would refer to some subword within it. Anyways, now all we did was to give this sentence to the tokenizer and get back a tokenized version of that sentence. Now we are going to give this tokenized version to the GPT-2 model generate function, and it will generate all the 10 sentences with alternative endings. So here top P and top K, these stand for the probabilities. So in the generator that GPT-2 uses, because every generation is just picking the most likely output given the previous sub sentence, you need to generate the next word. So all of these models, GPT-2 models, take in a sentence, and using that sentence it predicts the next word, and again it predicts the next word from there. So sequentially it continuously predicts the next word. Now in the next word prediction, you can pick the prediction with the highest probability, or you can use some variety there, which is picking from the top 10 generated words or top 10 probability words or things like that. So you can read further about this. These are called as text generation decoding strategies. So we are using top KP sampling. That is what we are doing here. Anyways, what our GPT-2 did was to generate 10 alternative sentences given our partial sentence. Now we are going to see all those 10 alternative generated sentences right here. So almost it looks a little bit magical when you first see it. All you gave was the old man was sitting under a tree, and then GPT-2 generated these 10 alternative sentences and had her nose stuck out and had an empty cup in her hand and listening to the music from her kitchen. So all these are alternative sentences generated by GPT-2. And looking at the stars, if you remember, the original sentence was the old woman was sitting under a tree and sipping coffee. That's the true sentence from the story. Now GPT-2 generated all these alternative sentences, and you can pick one of these sentences. Let's say the old man was sitting under a tree and looking at the stars. That you could give that sentence as a false sentence. Now the student who reads the original chapter knows that she was sipping coffee, and looking at the stars is actually a false sentence when concerned to the story, and he or she would answer it as false. So this is how you can automatically generate some false sentences with alternative verb phrases or noun phrases. Now coming to the topic that we discussed, now GPT-2 generated these 10 different sentences. But again, you want to automatically find the sentence which is farthest away from sipping coffee. How can you do that? Again, you can embed all these sentences into using sentence transformers. You can get you can convert a sentence into an embedding. Now you have your original sentence: old woman was sitting under a tree and sipping coffee. Now you have the embedding for that sentence. Now you have embedding for all these 10 sentences. Now you can use cosine similarity to find the sentence that is the farthest away from the original sentence, and you can take the farthest away sentence and use it as false sentence that you can give to your students in the quiz or assignment. That is what we are going to see. Here we are installing our sentence transformers library. Just we are going to restart our runtime because sometimes this once this library is installed, you need to restart the runtime. Otherwise, it will cause some crash. Yeah. Anyways, now I'm downloading the Distilbird based model. That is also a bird based model used to embed a sentence into a vector. And here I'm giving some mock sentences. So the original sentence was the old woman was sitting under a tree and sipping coffee. And I'm giving some mock sentences where I added gulping cocktail, drinking tea, and some other random things. So in ideal scenario, drinking tea, gulping cocktail all should end up at the very top. And we need to give the farthest away sentence as a false sentence. So we are going to get the embeddings for all our false sentence list here and also the original sentence. And in here, we are going to use SciPy library to find the cosine distances. And what I'm doing here is to compare the original sentence with each and every sentence in our list and get the scores and sort the scores and get according to the scores, I'm getting the corresponding sentences. So if you see, these are the closest sentences: drinking tea, gulping cocktail, because sipping coffee is our original sentence and we got the sentences that are close at the top. Now if you go farther away and pick these sentences, you can give these sentences as the false sentences. So I'm just sorting in reverse order, and you can see that any of these sentences could be given as false sentences because they have alternative verb phrases or noun phrases that are different from our original sentence, sipping coffee. Now we are done with the coding section and let's just go back. So in short, what we have just seen is that given any sentence, if you want to generate a false sentence, one way is to generate by replacing it with an alternative verb phrase or noun phrase. So this is the original sentence and we split our sentence with constituency parsing, and we used our split sentence and we gave it to our GPT-2 algorithm. It came up with 5 to 10 alternative sentences with alternative verb phrases and noun phrases as the ending. Again, we used sentence transformers, especially BERT-based model, to sort the sentences and find the most dissimilar sentence from the GPT-2 generated sentences, and that could be used as a false sentence. Now we come to the end of our talk, and I wanted to let you know that I created an amazing course on question generation using NLP. So you can generate all these types of questions like multiple choice questions, true or false questions, fill in the blank questions, match the following. So uh, I've created an awesome course that puts together all these types of question generation types, um, and you can generate these types of questions using state of the art NLP algorithms like GPT-2, BERT, and also T5 transformers. And for the purpose of this talk, I have a special coupon code that's valid for only a few days. So you can use PIEANDAI. So you can just go to bit.ly/question generation, and you get the Udemy course, and you can use this PIEANDAI as the coupon code to avail at a special discount. And as I mentioned, you can connect with me on social media. Just go to ramsri.ai and you can find all the links. And if you have any questions, you can email me at ramsri@question.ai, and I'll be happy to respond to your queries. So if you're solving any personal NLP problem, I can offer you a high level solution and respond back if it's a quick question. Always happy to help. With that, I'll open the floor for questions, and thanks a lot again, Manpreet, for giving me this opportunity to present.
It was so great learning from you today. Well, I
Thank you.
have a few questions for you.
Absolutely.
So first, I want to ask you: do you think it's how a person should learn NLP, and how did you get interest into NLP? Because a lot of people compare computer vision with NLP, and a lot of algorithms have been taken from computer vision. So, what are your thoughts on all of these?
Hmm. Great. So answering your first question, which is how do you get started with NLP and how did I come into NLP? So one thing is that whenever people are starting in the space of I broadly see there are like three different things where um, there is text-based AI, which we call as NLP. Then there is images and video-based AI, computer vision. Then, especially based on numbers and data, there's traditional machine learning. Of course, there's a significant overlap, and at some point, all of these mutually come together as well. But these are the broad topics, and also there's like speech processing, which could also come under a little bit under NLP itself, because you have Google Home and Amazon Alexa. That's also sub branch of NLP, which is based on speech. uh, Now, coming to how to get started, one thing is that I always suggest people that try out small projects in these different things. It could be traditional ML or computer vision, speech processing, or text as such general NLP, and try and see what interests you the most. So usually all these sub branches are so huge in itself that of course the underlying deep learning algorithms and the ML part or things like that could be somewhat similar, but each of it is also a ocean in itself. So one thing is to try and see what interests you the most, because some people are very visual, so they love to play with images. So they love to generate different kind of images using GANs, or they want to just classify images and see bounding boxes around things. I was one such person, so that's how I got started with computer vision. And some people love to play with text and find insights in it, just see how different things play together in text. Or some people love to just play with voices and classify voices, things like that. Or some people just love to do traditional ML, where it could be like credit card identification or predicting house prices or any of these problems, right? So see what kind of mode interests you. And one thing is that as people grow, they'll also develop interest on side things as well. It's not just like NLP is the only thing that you would be interested in and things like that. But to start with, it's good to get a flavor of all these things, and do projects in things that interest you the most and develop some kind of small specialization in that and then expand from there. And the biggest advice that I give to people is always solve practical problems. Then only you will relate your learning to real world. Because I had a huge problem, especially in my 10th and 12th when I didn't have internet access. I didn't know why I was learning any of the linear algebra or what was its use case in real world. So every time when I encountered math and physics, I had a huge problem mapping that to real world. Uh, but what happened was once I got to undergrad, I saw that, oh, all this linear algebra, all these cosine functions, etc., they are not learned just by itself. I can use the similar algorithms and probably identify things using computer vision. I can do similar images, I can fetch similar images or things like that. Then once I started seeing real world applications of that math, then I started learning more and more computer vision. And I like there are different approaches to this, and I always suggest start with a practical problem, then trace back the math. Of course, once you come to graduate level, you would have a basic understanding of stats and other things. So instead of just starting with all the heavy math intensive courses and getting uh, sometimes discouraged, rather start with practical problem. And let's say if they used cosine distances or some other Mahalanobis distance or something like that, then go back and see what is the distance metric and how that is used to solve. Or similarly, using any linear algebra things like matrix multiplication or inverse transpose, how are they used when it, how is an image represented as a matrix, and uh, done the similar things. So try and trace back like that. And sorry for the long answer, I'll just cut short. And how I got started was in the third year of my undergrad, I participated in a robotic competition where there was a top mounted camera and a robot was there on the pool table, and there were balls spread around, and the goal was simple: the robot should place those balls into the hole in a pool table. And all that was done completely using computer vision. So there's a top mounted camera that will identify the robot position and balls, and we use MATLAB and drive our robot that is connected to motors, and we drive our robot in the direction and put the ball. I realized that okay, now you're using actual math and all the things that you learned to solve a real world problem. It started from there, and to be honest, I was not an NLP engineer up until the last 2 years. I became an NLP engineer because of the startup. I thought, okay, now that I have AI skill set, probably I can attempt to do any problem. And then when we are working in edtech, we encountered this problem of automatically generating questions. And I started learning NLP. And to be honest, most of the knowledge was transferable. That means from computer vision, the ideas were borrowed into NLP, and from NLP, they were borrowed into computer vision. So it didn't take long for me to get started with NLP coming from computer vision background. And like I said, from there on, from my undergrad, I just started exploring into computer vision. What are the real world possibilities of it? And I saw that self-driving cars took off recently, and I started learning that in like 2017, 2018. From there, drone robotics and even like generative AI things and other things. Yeah.
Thank you so much. But as there was a recent post by you on LinkedIn sharing your earnings on how an entrepreneur earns, so how has been your journey through this? Because I recently received a message from a person that how do I get money from writing blogs on LinkedIn? But I, as a person, just write because I like to write. But I would like to know your opinions because you recently shared this post. And how do you encourage people to do these much stuff to the coming generation? And how important does it hold?
Great question. So I've heard a lot of things like blogging is dead in 2021 or 2020. So all these things, right? So uh, while the opinions might differ, I use blogging as not a way to generate money just from blogging, because I blog on Medium, and fortunately, since I lived in the US, I have a Medium account from US active, so I get money, or small money also from there. But essentially, the way I use blog is like this: that one is to showcase my ability. So I write very high quality NLP blogs. So when I'm applying for, let's say, a job, or even for a consulting position, the freelancing position, etc., the first thing that I put is my Medium blogs. So if they're working in, let's say, some specific niche area in NLP, I would find the blogs that are relevant to that, and I would put those Medium blogs there. So rather than blogs as a way to earn money by themselves, one way is to establish credibility with blogs. And second thing, and the most amazing thing that most people realize, is that with blogs you develop audience. And you know how I sold a 20% of my course sales come from my blog. Even if your blogs generate $0, let's say you created a great course on question generation using NLP, like I did. At the end of every blog where I did something with, where I explained something with edtech, at the very end I added, hey, great that you read through the blog content, and if you found it useful, you would also find my question generation course that I recently released on Udemy, that expands more on this topic, very useful as well. Please check it out. And most people won't believe, I got at least like 20% sales from my blogs. So over the last 1 year, I wrote probably, just focused on edtech and NLP, I wrote 10-15 blog posts, and at the end of every blog post, I added link to my question generation course. Similarly, whenever someone says blogging is dead in 2012, 2021, while blogging might not generate money on its own, one, it can build credibility for you. Two, you can link back to your paying things at the end of the blog. Or if you, let's say, you run a live course, you can point to the live course as well. So any of these, if you released a book on pact, you can link that to the blog post as well. And for people who are starting out, one thing that I encourage is that um, always have a passive income source. So even if you're doing a full-time job, perhaps try to develop a small social media following, um, because at the end of the day, even there's nothing wrong with either doing entrepreneurship or jobs. I have equal respect for both of them. But even if you want to just be in the job space and progress in the career, even if you build audience online and if you establish credibility, it's easier to get your second job if you just post with to your network than otherwise. And main thing is that one thing that I say is that the future is going to be digital. So as more and more things become digital, it is very important to even establish social credentials, credibility, right? So even on social media, it's very important to establish credibility. Whether you want to be in a job or get the next job, or even if you're starting out into a new venture, into an entrepreneurship venture, if you already have audience, you can tell to the audience that you're launching this product, and you might already have like 100, 150, 200 users already. So sorry, one thing is establish small streams of passive income. It could be through courses, or it could be just through blogging, or it could be just through YouTube channel where you build your credibility, and slowly increase the share of that passive income. And in the future, you can depend on it. If, let's say, for some reason you lost job, or if you see a massive potential there, you can take that full time. Or even if you just want to get your next job, you can use that as a strong networking channel. Yeah.
Thank you so much. I have just two more questions for you.
Sure.
As you know, this recent last year, Diljit was talking to Alexa, and he was trying to convey that please. Sing my song, and it could not recognize in Hindi and Punjabi. So, what are the challenges that you think are still there in the field of NLP in terms of low resource languages and this conversational AI and speech things?
Great. So, as you mentioned rightly, like a lot of work. Sorry, did you finish the question or
Yeah,
is a
yeah.
part of it? Okay.
No, no, I finished.
Great. So one thing is that a lot of research has been done in like English as such, but if you see linguistically, a lot of languages differ quite a lot from English. So there's not that much of research going on, in the sense that uh, a lot of commercial products, they are more focused on first offering English based solutions and then venturing into other spaces. So especially if you take to Indian languages, there's a company called live.ai. They had like text to speech solutions that were used by a lot of Indian companies as well. So it's so one thing is that there's limited data. Then secondly, there are limited players who are using the data to build models. One problem is genuinely the commercial aspect of it, where if big players put in money in like localization and using local languages and bringing them online and using NLP on that, then there is commercial interest from that perspective. Then secondly is also from the research angle, since a lot of research labs are spread out mostly in US and European nations. Of course, there are great research labs even in India, but sometimes it is because of funding to the research labs, to IITs or IIScs as well, that some research might be lagging. And I think one way it could propel forward is either government shows some interest and puts aside some funds to develop or custom NLP solutions in local languages to Indian languages. And also second thing is, as tier 3 and tier 2 audience come online, there's a massive need for them to use internet in their own native language. So that will propel the growth in terms of maybe like Swiggy offering uh, search and other things in local languages, and also all these massive unicorns that are coming up in India, right? They could propel the growth in local languages by driving NLP further. Yeah.
Let's see something in future that comes into this use as well for the common public to use. Last
Yes.
but not the least, if someday, now that you have a course, now you have blogs, what if you write a book, what would be it titled as? And what would
Sorry.
you like to write? If you get a chance to write a book, what would you like to write and talk about in it?
Okay. Um, so to be honest, I don't read books as much as others do, or rarely do I read books. One thing is that since I'm in ed tech, I understand that there are different kind of learners.
Yeah.
There are learners who visualize and learn, so they learn better by visualization. Then there are learners who will only remember if they practice on it, like hands-on things. So there are different kind of learners, right? And as for me, I saw that mostly video courses and other things. So book reading hasn't been much of like a personal thing for me. So in that sense, on a personal level, I don't read much books. So I don't know if I if I will ever write a technical book, I don't think I will, because I myself don't consume technical books much. But I think there is one thing that I really think about, like in the future, let's say, uh, if there is enough recognition for the work that I do, then I want to write a book, not mostly on like the autobiography side of things, but mostly it's like uh, how to be like how to ace productivity and make the most out of the time that you have, and as well as um combine multiple things and achieve success. By that I mean, um right now I've been in the creator economy of passive income, etc. Then I've been in the entrepreneurship space of starting companies and almost raising $1 million. Then I come from the core AI research background as well, right? So I always think, how can you put together all the learnings and package into one like good write up? It could be like a book or things like that, where you offer some kind of gateway for newcomers to quickly ramp up to like having world class impact. That impact could be in multiple ways, not just technically, but as an individual, how can you get to the point of having world class impact quickly, leveraging on multiple things?
Thank you so much for spending your Saturday evening with us and our community. And thank you so much, everyone, for joining us today. I'll share actually, somebody asked that hyperlink to your notebook. So I'll share it on LinkedIn and on YouTube description for anyone to use it. And until we meet next time, thank you.
Sure. Thanks everyone for joining on a Saturday. And I hope it was a useful session for you. And also, I want to thank Manpreet, because, like I always say, nevertheless, you do good work. There should be a good platform to showcase as well, right? And opportunity, giving such an opportunity for me to present as well. I definitely want to thank you from the bottom of my heart.